elements are called boron. What can be reason behind?
Sir, the first element is boron, that is why it is known as boron.
And rest of the element, they follow the similar configuration like the boron. Okay. Now see the next point. Here, these group elements show a wide variation in the properties. No, they show the wide variation in properties. What the variation are there? First one you see, boron is typically, first element you see, boron is typically a non-metals. Aluminium is metals, but so many chemical similarities to boron and gallium. Indium, thallium, and here is nihonium are the almost exclusively metallic in character. They are almost metallites, but not the correct, actually not the 100% metal, but the metallic characters are high character. Okay. As earlier you studied, that is down the group, down the group metallic character increases. This is the point. Now, here see the some of the more point we can see here. They are saying boron is fairly rare element. Okay.
Yes, sir.
Which is the rarest element? Can you tell me out of what we study? We study group 1, we study group 2, and we are studying this one.
Sir, I don't know. Sir, this
one element are there 10 power minus 10 in earth crust. Which one was there? In the earth crust, 10 power minus 10. Whether this is the beryllium, beryllium, magnesium, calcium, strontium, barium, which one? Or the lithium, sodium, potassium, rubidium, cesium, francium. Out of this.
Sir, I do not know this one, sir.
Okay. Okay, you check and you let me know. Now, mainly occur in the orthoboric acid, H3BO3. This is what is called orthoboric acid. So where boron is found in the orthoboric acid, or there is borax. Borax, that is Na2B4O7 dot 10H2. Or there is carnallite is there. Carnallite is there. Na2B4O7. Okay. Dot 4H2O. So here carnallite and the borax is having same. This borax, that is what the ladies use in the na sindoor. Do you know sindoor? That they apply na. When you go temple na, what we apply na. This is what the borax type of compound. Next one, in India, borax occur in the Puja Valley. Where? Puja Valley, Ladakh. And similar Sambhar Lakes, Rajasthan. The abundance of the boron in the earth crust is less than how much? 0.0001% by mass. There are two isotopic form of the boron, that is boron 10, that is 19%, boron 11, 81%. Aluminium is most abundant metal and the third most abundant element in the earth crust. Third most element in the earth crust, that is third. Okay. And it is the most abundant metal. In the metal, it is the most abundant, first position. But in the earth crust, its position is third. Now, right. In the earth crust, they are saying 8.3% by mass. After oxygen is 45.5%. And silicon 27.7%. Silicon means, you know, clay. Clay is silicon. Bauxite, Al2O3.
The silicon is a plastic type of material, so that is used to form a lot of things. It appears like rubber.
Okay, correct. Hey, where you go now? Beach. Have you where beach? No, like Marina Beach or Goa, you might have visited. So beach is what there? Any beach you go near around the ocean, what is there? Many clay are there. Okay. So this is what nothing but that is silica, SiO2, silicon dioxide. Next one, Na3AlF6 are the important minerals of the aluminum. Na3AlF6, this is. So this is called last class also, it came Na3AlF6. Sodium, no, Na3AlF6 are important minerals of the aluminum. Here in India is found in the mica, MICA, Madhya Pradesh, Karnataka, Odisha, where you are there, this is also there, and Jammu. Gallium, indium, and thallium are less abundant element in the nature. Nihonium has the symbol NH, atomic number 113, atomic mass 286, and electronic configuration is Rn 5F14, 6D10, 7s2, 72. So far, it has been prepared in a small amount and half-life period is its most stable is 20 seconds. Can you see the half-life period of nihonium, NH? How much is there?
Yes, 27.
What is the half-life period of francium, Sanu? That you need to write somewhere, then only it will be helpful. Okay, no problem.
Sir, half-life, so which elements I need to write?
Because francium is also francium, radium. Last element is radioactive. Last element. Their half-life is very less. It can be 12 days, 20 days, 15 days. Okay, like that. Like here, nihonium, how much is there? 20 seconds. Okay. I will send you half-life period of all the elements. Due to these
So just
reasons, due to these reasons, its chemistry has not been established. So NH is element, its chemistry is not established. Why? In 20 seconds, what you can study? Which property can you study in 20 seconds? So you cannot study all the properties in 20 seconds. So its chemistry is not established. Nihonium is synthetically prepared, radioactive element, here atomic, physical and chemical properties of element of the group living nihonium are discussed below. So we are not discussing the nihonium. Why? Because its chemistry is not established till now. Getting? So other we are discussing बैगन, आलू, gajar in thela. So boron, aluminum, gallium, indium, thallium. We are studying this element, but we are not studying the nihonium because nihonium is
nihonium is the last period element, last period element. Because it should be synthetic. We are not studying the synthetic elements.
Because its lifetime is how much is there? In 40 seconds, it is going to be decomposed completely. All the alpha, beta, gamma rays will come out. So what we can study in this period of time? Okay. First one is electronic configuration. Can you tell me what is the electronic configuration?
NH2,
NH2, NP1. Very good. So one electron is there in the p orbital and 2 electron is there in the s orbital. So this is configuration is there going to be what? NS2, NP1. Okay, so there is nothing is there in this one to discuss about the electronic configuration. Atomic radii is very, very important. Very, very important. See, I am discussing here boron, aluminum, gallium, indium, thallium. See, 1s2, 2s2, 2p1. Here is 1s2, 2s2, 2p6, 3s1, 3p, 3p, how much is there? 3p, 3s2, 3p1. Gallium, you see, gallium. Gallium is, here 13 is there, so we need to add how much? 18 in this one, 18. So it will be 31, I think, 31. So how it will be configuration, you see? 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p1. You can count out 2 to 4, 6, 10, 10 to 12, 12, 6, 18, 18, 10, 18, 10, 28, 28 to 30, 31. So what is there, Sanoy, here? You kindly be observant in this case little bit. Here you see the d electron is there, d orbital. And if there is d orbital is there, d orbital, no shielding effect, no shielding effect. It's not causing the shielding effect. So no shielding effect, more attraction. More, if there is no shielding effect, so it will be more attraction. So if it is more attraction is there, so a small size. So although size increases, but gallium is smaller than aluminum. So correct answer is boron. Then it is going to be gallium, then aluminum, then indium, and then thallium. So here you see, on moving down the group, for each successive member of the one extra cell is electron is added. Therefore, atomic radius expected to increase. Expected, here what the word they use, expected to increase. However, deviation can be seen atomic radius of gallium less than aluminum. Gallium is having less than aluminum. Getting? Yes or no?
Yes.
This can be understood from the variation is inner core of the electronic configuration, the presence of additional d electron. How much? 10 d electron offer only poor screening effect. We study in the periodic table, poor screening effect. For the outer electron, the increase in nuclear charge in gallium is considerably high. Consequently, the atomic radius of gallium is 135 is less than that of aluminum 143. This point you can make a note. This point.
Sir, which one? Please, I'm writing. Just 1 minute.
See, d orbital is there. D orbital no shielding effect. So more attraction, small size. In case of gallium. Have you studied the lanthanoid contraction? Have you heard about this one, lanthanoid contraction?
Sir, in physics, I have done, sir, the elasticity.
Lanthanoid contraction, actinoid contraction?
Sir, the length and height. I heard length and height. No, sir, I not heard.
Okay. There are many things in chemistry to teach. Which things shall we leave? Which things shall we teach? Because of the time foundation, many things we cannot study in detail. Okay, that I will tell.
This test also, sir, we are having the same hurry up in the last minute. Sir, can you please ensure that the next test we are completing the syllabus before the test also?
Sure.
Sir,
You also visited this time. So 2-3 class you missed.
so that is the problem. I understand, sir.
This
Sir,
time
but
not.
uh, sir, but from the next
This
test,
time, wait. This time we'll finish 1 week before the time foundation. 1 week before. This time, next exam, 2 week. I will
sir,
finish
I'm
very
very.
early.
Uh,
Uh,
Sir, the next test will be on 7 January 24.
when
7 January
February?
24.
Hmm.
Hmm.
We
So
are
they
having
are
the
having geo,
December.
hydrocarbon, environmental chemistry, and POC. Only these 4 chapters are there.
Let me check. GOC, hydrocarbon, environmental chemistry, POC. What is POC?
So POC,
They mentioned some other POC. What is it? But these are the very big chapter. GOC itself is too large chapter. Environmental
sir,
chemistry.
geo,
What is POC? POC I want to know.
sir, what is the meaning of GOC?
General organic chemistry. General organic chemistry.
Okay.
But POC I
So
don't
then
know.
that should be physical organic chemistry. Anything is existing like that.
Yeah. This can be. Okay. Okay, no problem. Polymer chemistry can be. Something will be there. Okay, not an issue. That I will finish. Whatever is there, it is
Sir,
there in the.
sir, I will get to know what that thing is. Sir, I will let you know.
No, I am having the book. I will take. That is 7-1. 7. So we are having this month of this month 3 week are there, na? 3 week means 6 class we will build.
No, no, sir. It's 7th of, not 7th of November, sir. We are having it in 7th of January. So next year.
That is what I am saying. This month, 3 week left. Next month full is there. December is fully there. And then we are having January 1 week. But you see, these are very big chapters. So 3 days is not enough. I will see. And 1 hour also not
Sir,
enough.
extra, what I think is extra classes are required.
That I will do. That part you don't worry this time. I'll take responsibility. I will finish that. You don't have to worry. You told that much is enough. Here you see. So this radii you understood, na? Radii, what I told. Radii, y increases, y decreases. Wait. Not there. Please wait. I just want to discuss one more topic because if you are knowing the topic, some extra topic that is. See.
Yes, sir. And sir, if you just can give me the introduction and the basic principles, then I can also study somewhat at my home and then I can
Yeah, I know. That is why some topic I am telling. Lengthenoid contraction is what? Contraction means decrease in radii. Contraction means decrease in radii. Okay. Of lengthenoid element. Lengthenoid. In the periodic table, you see in the bottom of element, there is lengthenoid elements are there. Getting?
Yes,
What is happening? Lengthenide is having 4f orbital and actinide is having 5f orbital. So when you study the d orbital, 6d orbital or 5d orbital. So what is happening? Firstly, the nucleus is there. Then it is going to fill. How it is going to fill? See, these are there. This is there. Okay. Suppose last cell we are going to study. Last cell we are talking. So last cell when you are studying, na, suppose you are studying the 5d orbital. So before 5d, which element is going to come? Okay, suppose it is coming, I think 4f will come, 4f. Okay, 4f will come, then 6s will come here, like that. Here you see the 4d orbital. If you see 4f, f orbital, any f orbital, no shielding effect. Getting? No shielding effect. If it is not shielding the attraction force, so if it is not shielding the attraction force, what will happen? Whatever the exerting nucleus is exerting, total it will be get attracted. Total it is getting attracted. So no shielding effect, so high attraction force. This is what? High attraction. And if it is high attraction, so it is going to be small
sir,
size.
why
Diffuse shape. Shape is diffused. Diffused shape. Its shape is like that now. Suppose its shape is like that, this one. Many diffuse. So attraction can go like that.
Okay.
Their shape is like that. Similarly, one more point is there, actinoid contraction. What is that is called? Actinoid contraction. Actinoid contraction, this is case of the 6d orbital, 6d element. 6d element. So 6d element, what will come? That is 5f orbital will come, 5f, like that. So here, suppose the last one is 6d, so 5f will come here. They are not causing, so the size decrease. So this decrease in size is called, what is called? That is actinoid contractions. The same reason what we study now, in that case, what the case here they mention, that is size decreases. The reason they have explained. Can you tell me what is the reason? They can understood from the variation is increase in the electronic configuration. The presence of additional 10 electron offer poor screening effect. What is offering? Poor screening effect for outer electron from the increase in nuclear charge in gallium. Consequently, the atomic radius of gallium is less than that of the aluminum. Are you be able to understand? No.
Sir, just 1 minute, sir. Can you please scroll that up one more time?
See, these electrons are there, na? So if you are doing the gallium, what you are going to find? This one. So here you
So
see.
done.
See, this is the suppose here is 4p1. So it can be 4s. Then here is 3d. 3d is no shielding effect. So it will attract more, na? Strongly it will attract. So this will be the smaller size. So that one. Ionization energy. Also the ionization energy is exception. Here is exception. What is the exception ionization energy? You will find boron will be there. Then it will be in gallium. Then aluminum. Then indium, thallium. Up see, its size is less, na, so high ionization energy. Here you see, the ionization energy value is as expected from general trend, do not decrease. What they are doing? As expected, they do not follow smoothly down the group. The decrease from boron to aluminum is associated with increase in size. The observed discontinuity in the ionization enthalpy value between aluminum to gallium and between indium to thallium, two places are there. Indium to thallium are due to inability of D and F electron which low screening effect to compensate the increasing the nuclear charge. Two places difference are there. Okay, kindly keep in mind the difference are not only one. Difference are two places are there. Means here is thallium. What will be there? Here is boron aluminum. Here will be indium. Here will be thallium. Now see the order here. The other ionization enthalpy as expected, this one. Third ionization enthalpy more than second than the first. The sum of the first three ionization energy for each of the element very high. Effect of this value apparent when you study their chemical properties that we will study. Now, so this one you see the order somewhere it will here. Ionization energy. See this one 801 highest 801 which one is there, that is boron is highest, then which will come 579, so this will be what, this one is gallium, then 577 aluminum, then it will come 558 and 589, so it will come 589 589 589,
Yes.
where it will go, 589 it will come, oh, see the order. And then what will come? 558. Lowest is 558. 558. Wait, now let me check the value. Okay, firstly, you write the values. So, see the values you see. The highest is 801. Then which one is going to come? 579 or 589? 589 will come. 589. Then will come
Yes, sir.
579. Then it come 577. Then it come 558. See the exception you see. Boron is there. Then what is thallium is there. Then gallium is there. And lastly it is in there. So kindly you see this ionization energy sometimes they ask ionization and atomic radii. Where exceptions are there that you need study very carefully. So these data you need not to memorize, but you need to keep in sequence. This one is do not ask, but here three element they ask. Three element that they ask, that is this gallium is more than aluminum with the reason. So because of the d electron. Here you see. No, this is the oxidation state. So this one you keep in mind. Now here the little bit exceptions are there. That also you keep in mind. When you solve the problem, this exception will automatically clear up. Next one you see, Sanoy. electronegativity. Down the group decreases. Down the group decreases. Down the group electronegativity first decreases from a boron
Sir,
to
it
aluminum,
increases,
then
it again
increases
increases
marginally.
marginally.
This is because of the discrepancies in atomic size of the element. So this see gallium is smaller than the aluminum na size. Gallium is smaller than aluminum, so their electronegativity also differ. If you want to see the values, here you can see the value electronegativity. Here it's 2 is there, that is okay. Then 1.5, but here you see 1.6. So here discrepancies are there that you need to see. Okay. So that one in a way is not going to ask all the exception. Only the boron, gallium and aluminum they ask. Physical properties. Physical properties is not that much important. You see, boron is non-metallic in nature. It is extremely hard and black colored solid. It exists in many allotropic form due to very strong crystalline lattice. Boron has unusually high melting point. The rest of the member are soft. So boron is what due to very strong crystalline lattice, boron has usually high melting point. See the keep in mind, boron is high melting point. They are what hard black colored solid. Here what they say, rest of the member are soft metal with low melting point, high electrical conductivity. It is worthwhile to note that gallium with unusually low melting point 303 Kelvin could exist. Wait, what they are saying could exist in liquid state during summer. So gallium existing in liquid state in summer. Its high boiling point 2676 Kelvin. Boiling point is high. Makes it useful material for measuring the high temperature. Density of the element increases down the group and boron and gallium. You know, gallium is used in the where in making what in making Sanoe, that is the thermometer. Thermometer for
Yes,
for
sir.
very high temperature. For very high temperature. Why temperature? That is, you see, the difference in the boiling and melting point. You see, melting point 303, boiling point, yeah, melting point 303. But boiling point you can see 2676. Let us see now here usage. When you study the usage, it is there. Usage. Yeah. Where it is being used. Here the last point is there. Usage there. The usage. Okay. So boron is being extremely hard refractory solid of high melting point, low density, very low electrical
Sir,
conductivity, find many applications. What is? First one is boron fibers are
yes,
used
just
in making
briefly I
the
want to say, sir.
bulletproof
Uh,
vest and light composite material aircraft. What is there? First one you see, bulletproof vest. Getting my
okay.
point because it is very hard.
Excuse me, sir, I want to say one thing, sir.
Uh-huh.
Sir, actually, in our house, sir, one of our teachers of the school have come. Sir, can I just go and talk to him once and said then I'm coming back. So actually, he came just now because
Okay, okay, okay.
tomorrow we are having one test tournament and from our school they are sending me. So sir, that is why he has come for some talking and
Okay,
like that.
okay. Go, 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 go.
Sir, I am here only joined only. I'm just keeping my mic muted.
Okay.
Okay.